Okay. Should be recording. Is the sharing working? Okay. Okay, you're inside. Okay. Okay. So the mic is not working that well. I called for the technician, and they will come and fix it. Okay. So just be silent in the first, let's say, 10 minutes. But I mean, the recording is working. That's why I'm using my microphone and not the room's microphone. Okay. Because there is always some problems. Okay, so today, before starting, we are going to see the schedule, okay, for next week, which is already online, Firefox. As usual, just check the website, okay, detailed schedule. And I didn't put I didn't write anything on the Telegram because, you know, this morning we have lecture. And so just if you're curious what you are going to do next week, again, lectures on Monday and Thursday. And this is the topic. I mean, today, after talking about libraries packages, we are going to talk about one of the most important topics in JavaScript, that is asynchronous programming. Okay, it will take basically 3 slots, even though one is devoted mostly to an example. Okay, to some examples, I would say. And then we will start talking about servers, HTTP protocol, I mean, actually just some records and so on, and then how to build a server in the way that is useful for our web application. So basically, building an HTTP API server, okay? Not really something that serves pages, because we are going to use another approach, okay? And of course, that will be lab. I didn't publish the lab yet for the second lab, because the first lab is not finished yet. A group of you is going to come today, okay, for the last slot of the lab, okay? So always check the schedule. That's a short message. I mean, the message in short, I would say. Okay, so we're going to talk about libraries and packages. We already use them. You remember DJS? DJS is a package that we downloaded from the internet, and that's a really big concern, actually, because when you download things from outside of your the area you control, it's always a potential security issue, right? So we are going to discuss this in more details today. Okay, that's the outline. So first of all, a little bit of definition, okay? A module, what is a module? We already saw it. It's a JavaScript file having its own scope, which is isolated from the rest. Actually, I didn't update the slide. Actually, won't be described later. We already described it. I anticipated it with respect to last year. Okay, so sorry for that. A library is what you already learned for programming, in programming languages. Okay, it's a group of functions in general, because typically you have functions, but it's some code that you can take from outside and use it, typically calling functions to perform some operations, okay, that have already been implemented in the form of in form of some code by others. Okay, you already saw one, like ending days and times. You don't want to spend time writing code to convert from string to time objects, so here, month, date, minute, second, etc. So trivial and so error prone, so just take something that has been thoroughly tested and verified by somebody you trust, I would say, okay? And what's a package? Actually, a package is a group of one or more libraries organized in a way that can be easily imported in your projects, integrated in your projects. Okay, you remember last time we just said, we just wrote npm install DJS, everything was done, okay? If the DJS is not a package, it's a library, maybe you have to download it, you have to link it. I mean, JavaScript is not compiled, so you don't really have to link, but you have to import it at least, and decide what to do, where to put the library, etc. Okay, a package already solves most of these issues. Okay, and so how do we handle packages? That is, by the way, the typical way in which we handle libraries and code, external code in JavaScript. there are two important concepts we need to get. Maybe you already have this concept from other languages, but you need to have a place where the packages are and are registered. So there is a list of the packages, and we call this list a registry, okay? So it's basically a database, but I mean, in short, it's a website where you can ask for the list, and you can get the link to download and so on, okay, to handle these packages, to get these packages and information about these packages. And also the information about dependencies. Often packages uses other packages to build their functionalities. We saw just a very simple example that is Day.js, but Day.js doesn't really need so much dependencies. Actually, I think it has no dependencies because it's just some code, okay, that just need to handle year, month, date, and so on with the usual logic that we have in mind for the calendar. But I'm not sure if today or next week we're going to see a more complex package like the SQLite3 package. So to handle a database inside a file, so the simplest, the most simple way that we can use in our project. But that is a more complex package because it relies on other packages like accessing, a package for accessing local files, a package to, I don't know, parse SQL, and so on, okay? Other functionalities that are provided by other packages, they are called dependencies. So without those dependencies, the package itself alone cannot run. And the registry register and knows which are the dependencies for each package, okay? Okay, there are several different packages, registries, package manager later, but several different registries around also for the JavaScript community, but there is one which is the most important one, okay? The most used, the largest one, okay, is the so-called NPM registry, okay? It has more than 2 million packages. It doesn't mean they are great packages. Some packages are really very basic or just experiment, just test, and so on. You can write a package and upload it to the registry, okay? So I would say, in any case, that's the way. That's the registry that we're going to use here in this course because it's the most widespread registry that we have in JavaScript. Here is the link as usual. You can go and check, and you see Day.js or whatever you want, okay? Or if you want to have, I don't know, say a package to handle trees because you need a data structure like a tree, I don't know, tree hierarchical tree structures, whatever, okay? You can search as you would search on Google for libraries in other languages, okay? Just as an example. Okay, and then once we have the registry, of course, we don't want to deal manually with these packages. As we did last time, we want to use a package manager that is basically a program that we install on our computer to handle all the issues related to packages. So downloading the package when we want to use it, downloading the dependencies needed by the package. So the package manager needs to know which is the list of dependencies. So in the registry, there should be a place where this list is provided, okay? And basically, this software tool automates the managing of packages, okay, in a standardized manner, okay? So in short, it's like an assistant to the developer to install the packages required by the developer when you are developing code, or when you're just using code, there is a list of the needed packages, and it recreates the environment and manages package version, their dependencies, and so on, okay? Keep in mind that there are also issues about versions, okay? There is a version of the package, they discover a bug, or they want to improve the functionality, they make a new version. Minor version, major version, whatever. So package manager also handles versions. And of course, the registry also handles versions. Okay? So that's the big picture. Okay? So we have the registry and the package manager. Okay? And now we need to choose a package manager. Actually, we already did it last time. Actually, we decided to use NPM for this course, which is also the most widespread choice. okay, in the JavaScript environment. And it's also the default for the Node.js environment. Actually, we installed the Node. I told you install Node, but I didn't tell you install a package manager. Why? Because Node automatically comes with this package manager. When we run npm, actually this npm command is a program, and this program has been installed when you installed Node.js, that is the JavaScript interpreter for the local system. Okay. Okay. There are other package managers, so if you really like other package managers, you can try them. For the exam, as usual, we ask you to stay with what we chose in this course, that is the npm. Actually, it's not limiting you that much because, indeed, it is also a package manager that handles the largest repository for packages in JavaScript. So typically, if you need something, you find it in npm. Okay. We stop a little for a moment. Recording. Okay. So we were discussing about the package manager. We are going to use the npm. Okay, and use npm for the exam. Okay, we don't accept anything that is not npm. But just because of practical reasons, because we have all the chain, all the tools installed with npm, okay, we installed Node.js without any other package manager, and so it's easier to test, it's easier to check, and so, okay? But again, this is not limiting you in any way, okay? Typically, if you really want to use a package in your JavaScript project for the exam, 99.9% is available in the npm registry. Okay, npm now is also the name of a repository platform that is basically maintained by GitHub. So you might that is, by the way, owned by Microsoft. So actually, if you look at its website, npm.js, and you might wonder who is maintaining it and so on. Okay, that's the answer. Okay, GitHub, that is basically owned by Microsoft. Okay, initially it was independent, but I mean, we're not expressing a judgment on this. I mean, just be aware of that. Of course, I mean, running a website and especially the repository where packages can be downloaded at any time. There are 2 million packages, all the people download from that place and so on. It's costly. It costs a lot of money, so somebody has to pay for that. Okay. Okay, so this is not a judgment on the goodness of one package manager versus the other. It's just the simplest option that we could choose. Okay, good. So now let's try to go into more details about what actually a package manager do. No, what does the package manager does. So. Example 1, we are developing an application like last lecture, and we want to import some functionalities. We know there is a library called the day.js, and we want to use it in our project. Okay? And so we tell the npm, the package manager, we want to use the day.js. We run a command for the npm case was npm install day.js. Okay. Well, first of all, we initialize the repository. Okay, the project. Let's put it aside for a moment. So npm install day.js. So what does the npm do to the package manager? It goes to the software registry. So basically a website. It has a set of APIs. So HTTP course to do, and it asks, is there a package named day.js? Yes or no? If yes, the answer also contains some information about the package. In particular, two very important set of information, that is where to download the repository. The package, okay, from the repository. So basically a URL, okay, npm js dot what was it com or what, well, I don't remember it, and slash repository slash day.js slash version 123, I don't know. Okay, URL. You download, you access that URL, and you get the binary file in a certain format that contains the package. Okay? And then you get some information together with the package, like the version, the dependency list, and so on. Okay? So the package is included in the project. We saw last time there's a folder in which all the packages go. That is the node modules folder. Okay? So it's basically a directory inside our project where everything, all the code and so on goes. Of course, the format of the packages is standardized. Okay? And also the format that is used to describe how to handle these packages is standardized. We already saw a file, that package.json. Today we will see it again. So we will have a look. It's a text file. It's very easy to check. And a lot of information is written inside this package.json about the packages that we want to use in our project. And then as a last step, it checks the dependencies and restart from point number 2 until all dependencies are met. It means the AJS, I mean, not for the AJS, but like SQLite 3 requires another package. We go, query for the other package, for the URL, download it, check the dependencies and so on until we solved, we downloaded all the dependencies. Very easy as a concept, right? Second example, just to tell you, it's not a system just to simplify downloading packages, libraries, and so on, but it's also a system that can handle the whole life cycle of your project, of your application, okay? So we already developed the project. Like you submitted the project for the exam, okay? And you submit it without the packages, okay? Otherwise, we get 100 JS packages, 100 SQLite 3 packages, and so on. And that's not a way to distribute software, okay? The stuff that is the same for everybody typically doesn't get distributed or saved or kept inside the main files of the project, okay? They are just dependencies, okay, in quotation marks, for your project, okay? And so basically the package manager is also able to reconstruct the set of libraries and packages that you need for your project, okay? From what? From the description it finds in the package.json, in the case of NPM or Yarn, I don't remember what's the name of the file, but they have a list of packages that are required by your project. So you give your files, index.mjs, whatever names, JS, MJS, and so on. These are the files that you developed, and you give them the package.json. And then who gets the project knows that first it has to run the package manager to download and install all the packages needed by your project. Okay, so that's the second case. In one case, we are explicitly adding packages. In the other case, there's a list of packages that are needed, and we are simply reconstructing the environment to make your project work. Okay? So the developer only shares the application code and does not need to care about the other code, the packages that will be managed automatically. Everything that is automatic is nice from the point of view of the developer, right? So, example, the JS. We saw it, and we try it again this morning just to show, remind you, okay? So we run 2 commands from the terminal, inside the Visual Studio Code, from the Linux terminal, whatever you want. It doesn't really matter, as long as you can run the npm executable file that is the package manager, okay? Just remember that the first time it's better to initialize your project telling that you're using npm, and that's why we run npm init. Okay, you can also just run npm install JS. It assumes a lot of default configurations that maybe you might want to change, and that's why we would like to run npm init first. Okay, so that is the structure. It comes out. Remember, the node modules, it's a folder. Maybe I should leave the slash here. So it's a folder where everything gets downloaded and put inside, okay? Package.json is the description. Index.mjs actually is the file where you developed your code, and later on when we have React and so on, we will have many files, okay? Because of course, when the project grows in size, you want to have more files. Okay, and then there is this package lock.json. We are going to discuss it in a few minutes. Okay, just have. I want to remind you how it works. Okay. Okay, just to tell you one more thing as well. Okay, we have this QA. Okay, so let's make a new folder. Example. Okay. Yeah. First thing I want to tell you. Create a new folder for each one of the project that you want to use that includes packages. Okay. In the first lecture, we just developed with one file, no packages, so there was no need to really create a folder for each new example we wanted to run. But for your clarity and to simplify things and so on, just create a new folder for each project you want to run that has, where you want to use the package manager, it has dependencies and so on. Okay? So now it's empty. Okay? npm init. Make it bigger. npm init, and you remember the questions it showed us last time. Actually, we just pressed enter. Okay. Actually, the defaults are pretty good, but this is just in case you want to create a package, you need to give a package name. But our project, we don't want to make it in the form of a package, so we don't really care. Version again. Description, if you want to put tester description, again, we don't care. Entry point. So somebody of you asked me during the lab, well, should I write index.js, index.mjs, and so on? As long as we don't run our project using the npm package manager, we don't really care. Okay? This is just what is run if you run npm run something. Okay? But we don't really use it. Okay? Test command, git repository, keywords, whatever, auto license. Yes, it's okay. Okay? What happened in the example folder? That's a package.json. Okay? So package.json is the file that has the description of all the dependencies needed in your project. At the moment, there are no dependencies. We didn't install anything. Okay? So how do I know? The keyword dependency is missing. And then npm install the JS. You need a network connection for this because the npm package manager is going to the repository, asking if there is a package named AJS, asking for the URL to download the package, the information, and so on. Okay? Okay. So it already downloaded it quite fast and gives you some information, but you can see here, updated in real time, a new keyword dependencies with sort of an object. The package.json is very similar in terms of syntax to what you write in JavaScript. We're going to talk a little bit about JSON, actually the JavaScript object notation, but just open a curly bracket and there's a list of keywords with the version. Okay, this symbol means the minimum version is 1.11.19. Okay, which is actually just the latest version that the package manager took, because we didn't say to take another version, so it just took the latest version of the package. Okay, it took not so much time because actually it has a cache to not to go to the repository every time. Register every time and download things again and again, just for optimizing things, but it's handled completely automatically. You don't have to care about this. Okay? If we start with a new package, more complex package, it takes more because it needs to go and download and so on. Okay? But again, the package manager is supposed to do everything for you, and you only need to know what you want to install, the versions, and it handles all the rest. Okay? And then actually we didn't write anything, but if you want to write something, you create a new file. Okay, index. We say to use MJS because we already know modules. They are executed in strict mode automatically and so on. And then you know that the first thing you should write is an import statement, okay? And yes, console log day.js, which is the current time with a certain format, okay? Node, okay, not node, not npm, node index.js, okay? And we get the current date. And we are able to use the package that is being installed by the npm. How do we know how to use the package? As I said last time, you need to go to the documentation and see what the designers of the package thought about how to use the package, okay? So, again, day.js. You can ask the ChatGPT, I know, all this stuff, but this is the official documentation, and in case you have any doubt, in case ChatGPT or whatever system suggests anything that doesn't look so correct and so on, this is the official place where to look for, okay? So day.js is, I think there is some link to the documentation, there should be. Code dependent, dependencies, no dependencies, you see. Repository, home page, okay? Home page, it gives you some idea how to use it, okay? Just be careful, I mean, we don't like vars, okay? The var keyword, okay? Let or const day.js. Oh, this is required, this is the common JS format. For the modules, we actually use the import. Actually, how do you know if the package supports ES6 modules or the common JS modules? Actually, again, you need to search somewhere in the repository, in Google, and whatever you want, okay? Maybe the best thing to do is just try, okay? If the import works, it supports the ES6 module. System, but actually nowadays 99.9% of the packages support ES6, okay, because it's not so new, okay. It's really 10 years that has been around, also for Node.js, okay. For the browser is sort of native. Okay, good. So let's go back here. What's inside the Node modules? We don't really care. But just because we are curious, right? We want to see what's inside. A lot of directories, files, and so on. Typically, there is the implementation of the module in the folder called like the package, in the folder called like the package. But typically, you see, it's really compact and really difficult to read and so on. If you really want to know what the package is doing, just go in the source code on the page of the developer, and you will find the code which is not being compacted and so on, so it's easier to understand. But this is just a curiosity, okay? The license, all the things, just to give you an idea how much information is written there. Okay, the SC means just show just the main directory. K in kilobytes, 2,000 kilobytes, 2 megabytes, okay? Just to download a very simple library like day.js, okay? I told you it's 2 kilobytes. Yes, this stuff is 2 kilobytes. The rest is 2 megabytes, okay? Because there are plugins, there's probably some, not sure if there is some documentation or not. I'm not really sure what's inside here, okay? Maybe there are other functions and stuff, okay? But again, just close node modules. We don't care about the node modules, okay? We don't care what's happening inside that. We just handle it and manage it through the package manager, npm, okay? Okay, good. Package lock, we are going to talk about it in a few minutes, okay? So import, and that's what we did, and you can use the library, okay? I guess, yeah, in the end, we will see the rest, okay? Okay, so now, you're from the cybersecurity course of study, but even if you don't, if you are not from the cybersecurity course of studies, are good things to know, to keep in mind. And also for computer engineers, I would say for everybody, okay, for every developer. So actually, we downloaded some software, some code, and actually with this package system, basically we downloaded it, we imported it in our code, and we run it in our code with the same privileges as our code, okay? And that could be a problem, right? Because we can do whatever we want with our code, I mean, allowed by the environment, but for instance, Node.js is a program running locally on your computer, so it can access your local files. Depending on the permission, it's true, okay, depending on what the operating system allows it to do, but it's a local program. So you import code from outside, you run it locally, it can do anything you do with the rest of your code, okay? This is a potential security issue. How can we trust the code we download? This is really big problem, okay? So there is one problem, is trusting the code, okay? It's not doing malicious things and so on. For you, for your computer, for your development environment, when you ship the application in production, so it is being used by the users and so on, okay? And there is also a second issue we should care about, availability, okay? If the package, any package or library and so on, and a specific version of that package is not available anymore, how can the project be run? So if GitHub, Microsoft, whoever runs the registry, at a certain point decide, oh, this is a bad package, I don't know, it has some problems, I don't like it because the author is not a good person, I want to remove it. I've been ordered by the government, by somebody to remove it. Any reason, we don't really care. This package is not available anymore, okay? You go to a new computer, you run your npm, okay, it needs the DJS, what's the version? DJS 1.11.19. You go to the registry, is that DJS? Yes. Is that DJS 1.11.19? No. And so? Well, this symbol means, it says, okay, any higher version number is fine, okay. If there is no higher version number, what are you going to do? I mean, this code is not available anymore. It's a problem for you, okay? Because maybe you use a function, a characteristic that was available only in this version and not in the previous versions of the package. So you cannot just go back in one version, minor, major, whatever, and hope everything works. Yeah, you can pray, you can hope, but I mean, it's not a way that you should use to develop your application, okay? I hope you agree with that, okay? So, there is the issue of security, and there is the issue of availability, okay? So we are depending on the fact that somebody else is making some software available somewhere in the internet, okay? And hope that they will keep it, they will store it, and it will leave it available in the future, okay? So these are the two main issues we should discuss now. Okay, so for trusting the code, you know that writing code in the computer is it's easy to write something that is wrong, okay? It's a very error-prone task. It's easy to introduce bugs, okay? Typically, this is not done consciously, so not done on purpose, but you know, sometimes malicious attackers might also do it on purpose, okay? So, inside the repository, there is already a way to check for known issues in the software. So I would say the first step, not the final step, but the first step could be simply, well, just have a look at if there are known issues in the packages. And so you can take an informed decision if you want to continue using the package or you might want to switch to another and so on. Okay? So, NPM audit. Okay, 0 vulnerabilities. It doesn't mean it checked the software. It just checked the registry if in the metadata information there is some known issue for the package that we have currently in the system. Okay? Somebody else must have uploaded this information and shared it with the community. Okay? But I mean, as a first step, it's good to check. I mean, if something is already known, why should I ignore it? Okay? Like, I don't remember what, I mean, I just copy pasted something. So it will happen for sure at a certain point in your project. Okay? Because bugs are discovered over time, okay, in the code. So somebody reports it. Hopefully, the authors, the developers of the package improve the package, so fix the issues, create a new version, major, minor, whatever. And you know that the older version that maybe you used in your project as this bug, and if you run this NPM audit, it will check, it will tell you, okay, there's an issue. What do you want to do? Okay? I mean, what do you want to do? Typically is, okay, download the newest version because hopefully has less bugs than the older version. Okay? The command to do it is this npm audit fix, which actually, I mean, we can run it, but it does nothing now because we don't have any issue. Okay? When we have the SQLite 3 that currently has some issues in the dependencies, not in the package itself, we will see how it works. Okay? But actually, there's nothing to do here. Okay? And you also see that nothing has changed. I mean, the version is still the oldest, the newest one. Okay? Okay, so that's first thing to do. But actually, the security is a process. It's not just a matter of running commands. Otherwise, a computer could do security by itself, right? So how can you trust packages written by others? I mean, there's no easy way to solve this problem. The only way is to have somebody who uses the brain and checks the code. Okay? Maybe today some AI can give you some suggestions, but the final judgment is on humans. Okay? So you should read and check the code yourself, or you should delegate this task to somebody else. Okay? Your organization, your company, some organization does these checks for you, and you trust the organization. At this point, you change what you trust. From trusting the code, the author of the package, you trust the organization who checked the package. Okay? Of course, there are tools that can help you, like formal verification tools that can be run on code, looking for suspect code, patterns, etc. Okay? These are just tools to help, but the only way in which you can actually be sure that the code does what you want is reading the code and make sure with your human intelligence that it does what you want. Okay? And of course, that means that you should not rely only on unknown, untrusted entities. You should maybe check also the reputation of the source, of the author, and so on. Okay? But they are just proxies. The only real way in which you can decide if you want to trust something or not is checking the code yourself. Okay? And by yourself, it means if you are alone, it's actually yourself. So in this course, actually, we have no possibility to do this because we are going to use dependencies and the time is limited and you want to learn new things and not just checking code by others. But if you are in a big company, like when you finish your course of study, you get a degree, you go to work somewhere in a company, bigger, smaller, I don't really care. if the company works well and cares a lot about security, there will be some developers, somebody like you, that is in charge of checking the code of all the packages, dependencies, and so on, libraries that are being used in your projects, okay? So actually, you just delegate somebody else in your organization that you trust that checks the code of the libraries that are being used. This also means, since resources are limited, that you cannot just download the libraries from wherever, the packages from wherever place in the internet, whatever version you want, and the latest version, and so on. It typically takes some time for packages, libraries, and so on to be accepted inside your organization, okay? Because you don't want to have to import malicious code or code that causes problems in your organization, okay? So this procedure basically creates an approved set of packages, in the case of JavaScript, that can be securely used in your project, organization, company, and so on, okay? So like, we just downloaded the AGS version, latest version, but maybe the version that was checked was not the 19, but I don't know, the 15, okay? So actually, we should make sure that we install only what is approved in our organization, okay? Because that has been checked, and so this does not pose a security risk, hopefully, okay? You never have a certainty in this field, okay? You never know if something is really secure or not. By the way, you cannot demonstrate that the code behaves in a certain way. This has been demonstrated in the past, okay? I mean, from the theoretical point of view, you are not sure that the codes behave like it finishes at a certain point and so on, okay? So actually, you can do, you can try to do as much as you can to ensure that the code behaves as you expect, but you're never sure, and indeed bugs pop up often, and you cannot really do nothing unless go back and check again the code and check if this affects you and so on, okay? So, let's say that at a certain point we have an idea of the packages that we can use and the version of those packages that we can use. At this point, we need to make sure that the package manager only uses these packages and this repository, these versions, okay? And it will we will need to discuss repositories as well, okay? So, the best way to force package managers to use only a approved package is to search and install only from a private registry containing only approved packages. All serious companies have one, okay? Serious, I mean big companies that have the resources to afford checking everything they import in their project. If you go to Google, Meta, these big companies, they don't just do npm and download from the internet. They download from a local repository, from a local registry, where there is a set of packages that has been thoroughly tested by internal staff, making sure that no security issues are present. Hopefully, because we are never sure. Okay. By the way, having a private registry and database, so the registry means the metadata information, and the database means the actual package you need to download, okay, from the central server of your company to your local computer for development. Having it also solves the availability issue, okay, because the package stored in computer system you control, I mean your company controls. Thus, it cannot simply disappear. If it disappears, you take the telephone, you call the IT systems in the company and say, okay, it's not working, please fix it. But you cannot just take the telephone and call Microsoft, GitHub, whatever. Well, you made a package disappear, and I mean, first, you have no telephone number, and second, they don't obey you, okay? While if it's an internal company issue, somebody will take care of it. Okay? If it doesn't take care of it, it's a bigger problem for the company. It's not just an issue for you. Okay? Because something is wrong in managing people, code, and so on. Okay? So, the package cannot disappear and solves the availability issue, and the package cannot change its content, okay? Because it's on your servers, and you control what is on your servers, okay? It's not like there's a developer somewhere that uploads a new version or changes the older version, and the registry allows it, and so on, okay? You have no control of about things done outside your organization, okay? Okay. The second problem, so not the availability, but the second problem can also be solved nowadays with some security techniques, in particular using hashes. I hope you know what an hash is. It's like a sort of, I don't want to call it signature, because signature is related to identity, but it's like something that you can derive from an object, in this case the package, and that is unique and cannot be forged easily when you change the content from which you start. Okay, so you change a bit in the package, the hash will completely change. It's not like you can change bits and hope to get the same hash. Okay, so if you know the hash and you keep the hash information about a certain package, you don't solve the availability issue, but if you download the package again from whatever place, you compute the hash again. If the hash matches, you are almost sure that the content is the same as the one that you had when you computed the hash the previous time. Okay? So if the hash didn't change, the content of the package didn't change. Of course, this is just probability. But in security, everything relies on probability. It's the probability that two hashes are the same with the content which is different. It's low enough, like 10 to minus, I don't know, 50. You are, let's say, sure for our purposes that the content is the same. Okay? Good. So, in short, this allows us to make sure that, what we get at a certain point from whatever source, even the internet, even the NPM official repository and so on, is the same as the stuff, as the code that we got the first time. Okay? If we preserve the hash and we compute the hash again when we download the code again and the package again. And this is exactly what is stored inside the package log.json. You remember we had this fourth file we didn't discuss about yet. It contains both, of course, the version, but also the hash of the package. Let's have a look. We downloaded the JS, package log.json. Okay. You see, there's more or less the same stuff that is in package.json, plus a lot of keys that include the version, okay, the URL, but the integrity key, that is basically an hash computed according to a certain algorithm. In this case, this is SHA-512, but there are plenty of algorithms to compute hashes. There are cryptographically secure hashes, hashes which are a bit less secure. Okay, NPM did a choice, maybe Yarn, the other package manager, did another choice, and so on. But we don't really care that much, as long as that there is a good hashing algorithm that is used in your system. And so, having this information doesn't guarantee you about the security of the code. Okay, it guarantees you only the fact that if you delete the package, now the node module disappears. Okay? Node module is no more here. So it means that the code cannot run, right? Because the import cannot find package.js. Okay? Now we install it again. Okay? npm install. We don't have to install .js again. The package manager will take care of reconstructing all the dependencies because they are already written in a package, so JSON and package log JSON. Okay? It downloads, it gets the .js again, but the thing you didn't see here and doesn't print this information is that since there is a package log JSON, it also checked the hash of the package. It downloaded now with the hash that is already stored in the package log JSON. Okay? If you change some bits, some characters here, and you do the same operation, we see a warning message from the package manager. It says, oh, be careful, I'm downloading something which doesn't match in terms of hash with the hash that we already have. Okay? So this is a good news because basically it allows us, once we have the hash, to download the content from any place. Okay? Which is very, very good for the package manager, but also for our applications later on in the course, because it means that we can exploit caches and servers around the world that contains these packages, and they serve it faster to our applications in practical cases. So when we run the application in production, without worrying about the fact that somebody is serving content which is different from the one that we approved, because there is this hash and somebody is checking the hash. Okay? So in development, the package manager is checking the hash. In production, at a certain point, when we import the packages inside the browser, if we put the hash, will check the hash. Okay? Good. So we are almost done. Okay? I would say 10 minutes and we're done. Okay? So forcing specific packaging. Having the package JSON also allows you to force specific package versions when you build the dependencies, so when you download the packages that you want to include in your project. And this is very, very useful, especially nowadays, where you want to reproduce environment in the same exact way. Okay, you know that today's you can run different, you can run systems in different environments with different set of libraries and so on, through containers, through virtual machines, and so on. Okay, so having the same set of libraries, packages, and so on is very, very important. And if you want to install exactly the version that you used during the development, you have an option to do it with the package manager, with the npm CE, means clean install. Okay, it basically doesn't search for the latest version of the packages or any version that solves issues with the packages that you might have in your project. It just relies on what is written inside the package log JSON. Indeed, it doesn't work if you don't have a package log JSON file. Okay? It just ignores the rest, destroys the node modules, and reconstruct everything as if it were downloaded from scratch, using exactly the versions specified in the package log JSON. Okay? So the difference with npm install is that if dependencies already exist in node modules, it just uses them. It doesn't re-download, reinstall them. Okay? While npm CE, clean install, starts from scratch. Okay? It's also often useful to solve issues that you might have sometimes when you mess up with packages. So npm CI, now it works. Actually, the result is the same because it deleted node modules, it recreated node modules. Okay? Actually, the content of node modules. If the package log JSON is not present, let's say we rename it, okay? You will see it says, I cannot run, okay? npm C command can only start an existing, with an existing package log JSON, okay? Because Because we need to know the versions and the hashes and everything to reconstruct exactly the environment that you wanted, okay? So for the purpose of this course and also for the exam, we will ask you to provide us not just the package JSON, but the package lock JSON, okay? I mean, it's not really about making anything more secure in our course, because our setup is very simple. We don't have a private registry. We don't have a private repository from which you can download the packages and so on. We want to give you freedom to use any libraries and so on. Just be aware of the limitation and the risk that you are encountering, okay? But just for to get used to good security practices, as we would like you to be when you finish the course, just commit the package lock JSON together with the package JSON in your project. I will do the same for the examples that we do during the course. So we all get used to this, okay? What might happen later on? Well, now we are in March. At the end of the course, we will be in June, beginning of June. For sure, some packages will have newer versions, okay? Maybe they discovered some bugs and so on. So if you do npm CI on an older project, like something that you did in the lab, maybe not this week, which is very simple, but next week with the SQLite 3 and so on, you will see messages like we saw before in the slides about issues, security issues, vulnerabilities, high, moderate, and so on. Well, that's because you wanted to build the exact same environment. You can try to fix it, npm audit fix, but remember, this npm audit fix doesn't really fix anything. I mean, it just downloads newer version, and hope that the newer version addressed the issues and they have no bugs. Okay, they fixed the bugs. Okay, so it's something that we will experience later on during the course. Okay, good. So, yeah. So one last comment about libraries, packages, and so on. You know that when you choosing a library is always a difficult, how to say, a difficult decision, because you are importing dependencies inside your project, and if you are not actively supporting the library, you're not developing the library and so on, you rely on somebody else's work, okay? And so, in short, you are praying that the guys who are developing the libraries continue working, continue fixing bugs and so on. Otherwise, you only have two choices. If the code is open source, you fix it yourself. Okay, it costs you money, resources, and so on, but at least you can do something. Or if the code is not open source, so you don't have the source code, typically you need to rewrite part of your code to use other libraries or implement the functionalities yourself and so on. A lot of work. Okay, so try to be really careful when you choose packages and libraries. It's really important, okay? It's not just, something that you can take lightly. Maybe you should involve your boss or the company's management and so on. I mean, not really for small things, of course. I mean, like the AJS, probably you are not using so many functionality from the AJS. Maybe you can rewrite it in a couple of lines, it's fine. But if you are importing a big library, you are deciding to use some libraries like we will do, for instance, with SQLite 3, okay? You are committing to use this system in your project. And if you want to use something else, you need to be prepared to the fact that you might have to spend time, resources, money, basically means in companies, it means money, and finding people working on this to solve potential issues that you might have in the future, okay? So when you choose libraries and packages, probably you should consider these four aspects. licensing, which is, I put it first because it's very important, because I know it's not a technical issue, but you need to make sure that the license is compatible with what you're doing. Otherwise, once you have your successful startup and you have made millions of euros, dollars, whatever, maybe billions, you get a letter from a lawyer saying, okay, you owe, you used our library, but you were not allowed to, and now either we find an agreement, you pay us some millions, billions, whatever, or you close the company, okay? So it's something that you need to really care about. Of course, nowadays, a lot of software is released with a very, let's say, with licenses which are very permissive, okay? Not GPL, not a general public license that implies you to have to include it only in general GPL projects and so on, but even more permissive licenses, okay? So this might not be an issue, but just be aware of the fact that the first thing you check is, am I allowed to use it, okay? Of course, now you are in the university, you don't care that much, nobody will come to us and say, well, okay, you couldn't use it. But we are trying also to use freely available code, so, with permissive licenses and so on. So, we don't really have an issue here. But when you are in a company making business, making money and so on, these things are important. And then after that, the technical issues come, okay? Like, am I using a library that has been developed like yesterday by an unknown developer that maybe tomorrow likes to do something else? And so if there is a bug, I don't know what to do. I need to solve it myself. Hopefully it's open source, I can do it, and so on. Or am I using something which is well established in this community? I'm using, like in this course, we try not to use unknown libraries. Like Day.js is well established. Before that, there was Moment.js. We stopped using Moment.js because it was not well supported by the community anymore. There was sort of fight or discussions going on, and nobody was going to support it anymore. So I don't think it's a good example of choosing a good library in the context of this course, okay? Even though probably the latest versions for what we want to do is more than enough, okay? But we want to use something which is actively supported by the community and for which there is, hopefully, a commitment for long-term support. And then things might happen, like with Moment.js. Somebody has discussion with other developers and the project forks and you need to choose a path, one path or the other and so on, and maybe you need to do modification to your code when you have new releases. This might happen. You cannot do anything. That's life, I would say, okay? And then there is the security aspect, okay? So once you decided to use a certain library like SQLite 3, did somebody check the code in your organization? Maybe, or in another organization you trust, somebody did an audit on this code, okay? So audit means not the command, really check the code manually and with tools and so on to make sure there is nothing strange inside the code. Okay, this kind of attacks already happened. It happened even on the Linux kernel. You can ask my colleagues, which are more expert than me in this course of study, but it's easy to, not easy, but it might happen that people insert vulnerabilities done on purpose, okay? Put on purpose in some code. Okay, it happened in the NPM register as well, a lot, because anybody can contribute packages. You don't have to be anybody or have any sort of support from the community to introduce, to upload a new package. They just publish the package. You create your signature. You say I'm whatever name you think. You don't even need to use your real name. A lot of people who use nicknames and so on, contribute a package, and then people start trusting you, and people start using your library and so on. But does anybody check actually that you wrote code which is secure in the sense that it doesn't do anything that is unexpected, okay? Like, for instance, in companies, for instance, issues that might happen is that you import a package, a library, and they simply exfiltrate some information, okay? They just run, let's say, HTTP request around your private network, okay? It maps your private network in some ways, discover the names of your computer inside the network and so on. At a certain point, it makes another call to another server outside your organization and sends some of this information, okay? This is already a security problem. Even though they didn't destroy anything, they didn't do anything to your applications, the stuff that you are developing, distributing, that you are using to make money and so on. But I think you agree with me, it's not nice to have somebody who is spying you inside your network, right? If it's a private network. And so this is the kind of thing that should be checked first, okay? I mean, maybe not first. I mean, first is the library, the package does the work it's supposed to do without breaking anything or destroying anything, okay? Remember, this code runs in your machine. Even if it's a development machine, it can access your files, it can delete files, it can go around and do anything. It can be done by a machine in the private network of your organization. And then lastly, I would say documentation and code quality. Try to use something which is more or less well documented. It's not always easy. You know, the programmers are very lazy and don't document code that much. Nowadays, there are AIs that can read code, give you hints, and so on. So this aspect is a bit less important, I would say. Okay, but of course, you have a very, very nice library. You don't have a clue how to use it. It's mostly useless, right? Even if it's the best library in the world. Okay. So this is just a comic, very famous comic. Okay, all the modern infrastructure might be built on some library package that has been basically maintained by a random person, meaning somebody who has no, let's say, a person that is not so known in the community, is not paid for doing that, and so on, since a lot of years. Okay. It happened. Actually, these things happened. It was, for instance, of course, it's not a fundamental library. It could be just the logging library, just to log error message into a console or a file and so on. Okay? It happened, for instance, with the log4j library, if you know. Okay? Somebody stopped maintaining it, or maybe in that case, I'm not sure, introduced something that was like a security issue and so on. Everybody was using this library, just logging. What do you think it happens? I mean, we're just passing string and print strings, okay? Just be careful, very, very careful. I know it's like being paranoid, but security is sometimes being paranoid about things, okay? So I think this is the last advice from the package manager point of view. So nowadays, we are aware of what we are doing with the npm. Okay, we do npm install. That's what we are going to do in this course. Okay, I'm not pretending that you check the code of libraries and so on. If the library doesn't work, probably we are going to choose another library because we don't want to spend time debugging others' code and so on. But think of what you are doing, especially when you finish your degree at the Politecnico, at the university, and you go outside, and there are all the security issues to which you can be exposed. Okay? Okay, so I would say we have a 10 minutes break, something like this. If you have questions, of course, I'm glad to answer you here. And otherwise, afterward, we start talking about asynchronous code. Okay? You already have the slides online. No questions, I guess? But feel free to ask. I mean, don't be shy.